Hello, my name is Steve Bowler, and in this video we're going to be taking a look at trace options. Specifically within trace options, we're going to be taking a look at basic trace option functions. So what I'm going to do in this lab is I'm going to lay a solid foundation on trace options. I'm going to show you why and where you would want to use trace options. And if you're familiar with the Cisco IOS, then you probably have used the debug command, and what the trace option command is going to allow you to do is similar to what the debug command allows you to do. So I'm going to go ahead and explain all of this in detail, but first let's go ahead and take a look at the network diagram that we have. We have router 1 and 3. They are both connected to each other via gig E001 unit 0, and they have the IP address of 13.13.13.0. Router 1 is the .1, router 3 is the .3, and that is a /24 subnet mask. Router 3 also has a loopback 0.0 interface with the IP address 3333, the /24 subnet mask. And router 1 and 3 are both in OSPF area 0. So in this lab, what I'm going to do is I'm going to show you basic trace options using OSPF as the routing protocol. So the first thing we're going to do is on router 1, we're going to go ahead and bring up the connection between R1 and R3. So we'll get in a configuration mode. We'll do the command set interfaces gig E001. Again, logical unit 0, family inet, with the address of 13.13.13.1 /24. Let's go ahead and commit and quit. And then on R3, we'll go ahead and do the same thing. We'll do set interfaces gigi 001, logical unit 0. The family is going to be inet, and the address is going to be 13.13.13.3 /24. So if we go ahead and commit and quit on R3, now we should be able to ping between R1 and R3. So we'll do from R3 ping 13.13.13.1. We'll do a rapid ping with this count of 1000. And as you can see, we have reachability. So the next thing we want to do, if we look at our network diagram, is we want to configure OSPF area 0 between R1 and R3. So we're going to do that by going on to router 3. We'll do the command set protocols OSPF. We'll specify our area, again area 0. And then we're going to do the command interface, followed up with gig E001.0. We'll go ahead and commit that on R3, and then on R1 we'll do the same thing. We'll do set protocols OSPF area is going to be area 0, and then we're going to advertise into area 0 our gig E001.0 interface. So we'll give OSPF just a second to converge. And the trace option function is very simple to set up within the Juniper Junos. So the first thing we're going to do is we're going to create a file, and then we're going to go under the instance, or in this case it's going to be a protocol we're going to want to log the information in. And in this case we're going to be using OSPF. So we're going to show you how to set a couple of flags within our trace option to flag some of the different commands. In this case we're going to look at flagging hellos and events within OSPF. And then we're going to send these events to a trace option file. So let's go back to router 3. Let's see if we have the neighbor relationship up. So we'll do the command show OSPF neighbor, and as we can see now we have created or formed a neighbor adjacency with R1. So on R1 what we're going to do is we're going to set up a trace option. In this case we're going to be using OSPF, so we're going to do the command set protocols OSPF and then use the space question mark, and then we're going to see one of the second to last option we have is trace options. So again, before I do this with OSPF, I just want to show you that you can also set up trace options with interfaces and with a lot of other things. Even like if you go into routing options, you can do trace options from there, and so on and so forth. So it's not just the protocols. You can do also, if you do set interfaces trace options, then you can flag events under the interface as well, like change events, configuration states. You can do all, and this is a very chatty, you'll get a lot of output if you do a set interfaces trace options flag all. I advise that when you look at this, you make your file size very large, because you're not going to catch a whole lot with the default function of trace options. It's only going to be 1 meg in file, I believe, the file size. So you want to make your file size larger if you're going to do a set interfaces trace options flag all. So that's going to catch a lot of events, because you got to think about it. You're looking at monitoring all the events that's going on across all your interfaces on your router, and then you're going to save those to a file. So that file is going to be very large because it's going to have a lot of stuff in it. So in this case we're not going to look at trace options on a per interface basis, or on all the interfaces in that case. You could also do this. You could do a set interfaces and then GIGI001 and then trace options. So you're only going to catch our get commands and output just from GIGI001, whereas before with our set interfaces trace options command you're going to get all of the interfaces. So again, you want to be very specific in what information you want to get, because if you're not, then you're going to probably end up with more more trace option data that you really want. So in this case we're going to isolate our trace option down to OSPF traffic. So set protocols OSPF, and then if we do a question mark you can see that we have the trace options. So we're going to do set protocols OSPF trace options, and then we're going to create a file. So if I do the file option and then do space question, you can see that we have, or we can create a file name. In this case we're going to name it, we'll just name it OSPF trace, and then hit enter. So by default this file size I believe should be 1 meg. I might be mistaken. So our first step is complete. We have created a file, and now the second option, or the second part of the trace option, is going to be going under the set protocols OSPF trace options, and then if we do a question mark you can see underneath file we have the option for flag. So what the flag is going to do is tell us, okay, what exactly do you want to capture? So if I do set protocols OSPF trace option flag and then hit a question mark, you can see that we have a lot of events that we can catch within OSPF. So we have all, general, hellos, packet dump, route, policy, states, So as you can see, a very lot of, I'm sorry, not a very lot, there's a lot of information. So if we were to just to do a set protocols OSPF trace options flag all, then we better be prepared, especially if we have a lot of interfaces running OSPF and a lot of routes, then this could get ugly pretty fast. So let's do set protocols OSPF options flag. We're going to do just the event flag, and then we're also going to do the route flag. I'm going to commit and quit, and to view your file that you created, in this case it was, I believe, OSPF trace, we do the command show log and do a question mark, and if we go to the top, oh, let's see, where did it go? It has disappeared on us. Let's do this. Let's do a show log. Doesn't look like we're seeing it. Give me 1 second. Let's do a show configuration. And let's see. Let's do show configuration. OSPF. I'm sorry, show configuration. Protocols OSPF. So we have the file that we created called OSPF trace. So if I do a show log, where is the OSPF trace? Sorry, I'm looking in the wrong place, I believe. If I do a file, list, var, log, let's see if we can find our, I don't see it yet. Let's do this, show configure. See, this is a good time to troubleshoot. Show configuration protocols. We have OSPF, we have a file, our trace option, named OSPF trace. So where is this file? I don't see it. Maybe I didn't create file OSPF show log. I don't see it here, and I don't know if I am not looking in the right place. This should be the right place to look. Let's do this again. Let's do set protocols OSPF trace options file, and then we'll just name it trace options. let's do show protocols OSPF trace options. So our file name is Traceoptions. So let's go ahead and try to do this now. So you all saw that it did not show our file that we created. Let's do this. Let's do a show log question mark. And now you can see it. See, I swear I wasn't going crazy. So now we can see that we have our trace options file. So now if I do a show log trace options, we can see that we are getting some information within OSPF. Now, if I do a show configuration protocols OSPF, again we have the flag for events and we have the flag for routes. Let's do this. The event is going to be, it's pretty ugly debug, or not debug, but it gives us a lot of information that's really, I don't know, really stuff that we don't want to see at this point. Let's go ahead and do this. Let's change our trace option. Let's do a delete protocols OSPF trace options flag event, and then we'll do set protocols OSPF trace options flag hello. So that'll be a little more friendly for us. Let's go ahead and do a commit and quit. And now let's go ahead and do a show log trace options. And now we can see that we are receiving and sending hellos. So again, just wanted to let you guys know, I don't think I was going crazy there. You guys saw it too. When I did a show log question mark, I didn't see my OSPF file name, and that was very strange. The OSPF trace file name was not there, and I know that's what I created. So what I did was I went ahead and just renamed it to trace options, and now we can see that our file is there and it is working properly. So again, that was just a weird hiccup. Never seen that happen before. So don't you love it when stuff like that happens right in the middle of your videos? It's awesome. Okay, so back to the point of the trace options is, as you can see, is we are able to log a lot of important information. So in this case we have logged hellos, and we also have routes being logged. So the way we're going to use the routes is, and one more thing I want to show you before I go ahead and show you how we're going to use the routes trace option within OSPF. Let's go ahead and do the command monitor start, and then we can see that we can start one of our files. In this case we're going to start our trace option file. So if I do a monitor start with the trace options file name, you can see now that we are getting traffic in real time, just like we have if we did a debug IP OSPF hello, our debug IP OSPF packets on a Cisco router. So again, the way we did this is with the monitor start, and then we specified our file name. So in this case was trace options. So now we're seeing the hellos being sent across to router 3. So the next thing I'm going to do is I'm going to go to router 3. I'm going to advertise the loopback 0.0 interface into OSPF area 0, and then we're going to see what happens from router 1's point of view. So on R3 we're going to do this by going and under configuration mode, and we do the command set protocols OSPF, again in area 0. We're going to advertise interface loopback 0.0. So we'll go ahead and do the command commit and quit. And now what we can see the 3 network being learned and being logged into the trace option under router 1. So again, if you ever want to stop this, you just do a monitor stop, kind of like a unall on a Cisco router, or undebug all. So we do a monitor stop, that stops our monitor of our trace option file. So let's do this. We'll do a we'll do a show log trace options. We'll go ahead and try to show you exactly what was going on. So once we advertise the 3 network into OSPF on R3, and on R1 we have the trace option flag set for routes, we saw that we had a change, and now that we saw that the 3 network was being learned and added into the routing table on, or the forwarding table on R1. So if I do a show route OSPF, or show on R1, if I do a show OSPF route, we can now see that we see the 3 network, or we are learning the 3 network. So we can go ahead and try to ping that. See that we have reachability. Also do ping rapid. We're good. So that is a very quick look at the trace options function. How to set up trace options. In this case we used OSPF as the example. Within the OSPF protocol we created a file. The first file was named OSPF trace, and for some reason when we did a show log it did not come up. But you guys saw, just like I did, and I apologize again for wasting about a minute of your time, but I just wanted to show you without stopping the video that I wasn't going crazy. I didn't see an OSPF trace file. So what I did was I went back under R1 and set the trace option. I didn't delete the file. I'm sorry, I created another trace option file, and in this case, if we do a show log, it was called trace options. So once I added that, it showed up when I did a show log, and then we were able to proceed with our lab. So again, there's really 2 main points to the trace options that we saw in this lab. The first one was to create a file name, and again we can also, within creating a file name, we can specify the size of the file. We just left it to the default for this example. And then the second option was to flag the events that we want to send to this file. And in this case what we did is if we do a show configuration protocols OSPF on R1, we flagged the route option, and then we also flagged the hello. When we looked at the log for the trace options file, we were able to see all of our OSPF hello traffic that we were receiving from router 3. And then the last thing that I did was I went to router 3. I advertised the loopback 0.0 interface into OSPF area 0 on R3. We went to R1. We did a monitor start, then the file name, which was trace options. I advertised the network into OSPF on R3, and then we were able to see in real time OSPF add this 3 network into its forwarding table. And then we also were able to ping the 3 network. So that is a very quick overview of basic trace option functions. we showed you what you would use the trace option for, and we explained the Syscall equivalent, which would be a debug command. So thank you for watching this video, and I hope to see you in the next one.